Facial recognition is a biometric authentication technology used to map human faces to identities. This technology has many applications, including identification by governments or companies, device security, and social media. The use of facial recognition has rapidly expanded over the past few years, with most smartphones on the market now being equipped with facial recognition technology. Generally, the sensor used for facial recognition is the front-facing camera, but in more advanced cases, this is combined with lasers to capture a 3D image. Traditionally, facial recognition has involved measuring the distance between a person's facial features and comparing the measurements to those in a database. However, over the past decade, the use of deep learning has become more prominent. This method involves using an artificial neural network to compare facial scans to the database. Many facial recognition products combine both methods for a more accurate identification.
In the past decades, as facial recognition technology has matured, more and more companies and application developers has begun to integrate it into various products to reduce user operational burden. Unlike the early days of facial recognition, which relies primarily on 2D images, today's technology not only relies solely on flat images, but also employs multi-dimensional data acquisition technology, such as invisible light, infrared dot matrix, depth sensors, and 3D modeling to obtain richer and more accurate information about facial features. Apple's Face ID is certainly a compelling case in this field of development, setting new standard for the industries in terms of accuracy and user experience. So firstly, let's go through a video to learn more about it.
With the iPhone 10, your iPhone is locked until you look at it and it recognizes you. Nothing has ever been simpler, more natural, and effortless. We call this Face ID. To make Face ID possible, it took some of the most advanced technology we have ever created. And much of it is packed right up here into this tiny little area at the top of the display. We call this the True Depth Camera System. And it is made up of incredible state-of-the-art technology. There's an infrared camera, a flood illuminator, the front side camera, and a dot projector. And that's not all. There's also the proximity sensor, the ambient light sensor, the speaker and microphone, all packed into this True Depth Camera System area. It is amazing. And here's how it works. Every time you glance at your iPhone 10, it detects your face with the flood illuminator, even in the dark. The IR camera takes an IR image. The dot projector projects out over 30,000 invisible IR dots. We use the IR image and the dot pattern, and we push them through neural networks to create a mathematical model of your face. And then we check that mathematical model against the one that we've stored that you set up earlier to see if it's a match and unlock your phone. Now, this all happens in real time. It all happens invisibly. You don't see these things going off. It's incredible. It just all works and all happens. When you set up Face ID, you just follow the on-screen instructions, and it tells you how to move your head around in the camera so Face ID can recognize your face. And that's it. You do that once when you set it up. And Face ID learns your face. Even if you change your hairstyle, you decide to put on glasses, you're wearing a hat, or you do it up any way you do it, Face ID learns your face. It learns who you are. And it adapts to you as your face changes over time. Let's say you start to grow a beard. It works in day, it works at night.
Pretty cool technology, isn't it? Apple's approach to facial recognition is what most mobile apps use today. How does this work? First, when you look at the device, the IR camera and dot projector on it will acquire the IR image. Neural networks then processes data into mathematical models. Finally, the detection algorithm will compare this model with models in the database. If they match, the verification passes. When the user set it up, the user is asked to move their head and let the camera acquire facial images from various angles to generate a model. This process uses the eigenface method, which is also the most classic facial recognition algorithm. This algorithm processes the image and gets the main features as standards. If the features of any image meet the standards, it means that the faces are consistent. The logic of this technology is simple and can avoid the impact of users unwearing. It is a very popular and easy to use method. After talking about the process, let's talk about the application. Apple's Face ID uses facial recognition to confirm the user's identity, which includes unlocking the phone, payment verification, and even security. Facial recognition technology has a wide range of application in this area. First of all, face recognition replaces the traditional password verification. Users only need to point their face towards the camera to complete mobile phone unlocking or payment verification without having to enter a password. Its faster and more convenient technology improves people's efficiency and promotes the process of digital life. Of course, it can also help reduce queue time for checking tickets. In terms of security, facial recognition technology can accurately identify users during security checks, such as at airports, reducing the risk of illegal activities.
While we enjoy the convenience brought by facial recognition technology, we must not overlook the challenge it presents. In today's growing digital age, mobile devices have become integral to our daily lives. On those devices, we expect apps to respond instantly. Facial recognition being a core feature raises an essential question: how can it efficiently recognize face with limited resources? When we unlock our phone or use various apps, facial recognition process vast amount of data in a short time. This requires strong computational power and demanding high performance from the device. Also, different extensional factors like lighting and angle pose even great challenge to recognition algorithm. This means to maintain accurate recognition, device consume more energy, which is a significant challenge for battery-limited mobile device. At the same time, we can't ignore the privacy and ethics issues surrounding this technology. Facial recognition is based on our unique facial feature, essentially use a very personal identifier. If a device or service isn't secure enough, the sensitive data might get stolen. Attack could misuse it for criminal activities. Moreover, how facial data is collected and stored in a major problem. How can we be sure company wouldn't misuse this data or sell it for advertising or other business purposes? So while we enjoy the benefit of facial recognition technology, we must deeply consider the complex issue related to it. With the new technology, we need to see both the potential benefits and the possible risk. Thank you for your lesson.